Hello, this is Philip Brooks from Backwoods Brooks Knives, and over the past few days, I've been in conversation with a fella from CRS Firearms, I do believe. His name is Matt, and he recently did a video comparing bayonets versus combat knives, and he had a Kabar Clone there, and he was a little bit unsure of what the fullers were for. So we had a conversation in the comment section where we were trying to discuss what they were actually good for. And historically, fullers have been used to reduce the weight of a blade while maintaining most of the structural integrity of the blade, the same way that an I-beam retains a lot of structural integrity without weighing the same as a solid beam of the same dimensions. Granted, the solid beam is going to be stronger in many ways that the I-beam won't be. However, when weight is placed on the top of the beam and you have that web in the center, that takes the majority of the tensile strength. So that's how a blade works in that section. It's very rigid, in the plane of where the blade itself is. So the knife edge to the spine, from the edge to the spine, is very rigid going that way, but it's a little bit more flexible on the side for if you're bending on the flats. So what we're going to do is I'm going to make a Kabar clone. And what I'm going to do is I will test it in a few different mediums. I'll chop with it. I will try to mix up some ballistic gelatin. And we will see if we can use some sort of beef or pork roast to stick it into and see what the difference is, if any, that having what some people have termed blood grooves is actually useful for anything other than lightening the load. We will weigh it. I have a plan to use bottles and cans for some fluid reduction. See how fast fluid can pour out of a hole made by a knife if the knife is left in with a knife that has flats on it versus a knife with fullers, which, I mean, if you're going up against something that is not soft like a bottle, it will definitely help. But we'll also try it with some sort of a rubber or something like that. We'll have a bunch of fun with this. But first off, we need material. So I have a chunk of leaf spring here. This is our 5160 steel. And so I'm going to use our hole here to our advantage. So what we're going to do is we're going to come up, we're going to cut this like this with the torch. Then we're going to cut this back like this. And let's see, that's about, I want the end blade to be about 8.5 to 9 inches. And since I need it to stay relatively the same thickness, I can't do a lot of hammering on the flats. So that means that it's going to have to be close to final length, because then I'll be able to draw out the tip and I'll be able to draw a little bit on the sides before I bevel, which will also make this wider. So if I can get my Leathermans out one-handed, this is 9 inches. So that is about where we want to be, is right there. So we will come in like this. And then that's our cutoff. So let's see. We'll come and chunk out Yeah, so probably we'll just cut right off like this. And that should give us enough to draw out a tang. Because we'll hammer from the top to get material down to center line right here. And we'll go center line right there. And that'll be our tang running back through like that. So let's get this cut out and we will do some hammer forging and make this come out to our final shape, or our basic shape is what it would be. So I'll turn you off right now and then we will continue. Okay, now let's see if I can do this one-handed. Close enough. It should beat off with a hammer. Get some of the other stuff out. Come on. Okay, this is very difficult with one hand, so I'm going to turn you off. Bye. Well, that looks lovely, doesn't it? So, what we'll do is this is where our tang is going to get defined. So this part turns into the ricasso. Here's the blade. And it'll travel up and this will get mushed to the proper dimensions. And all of this will get a bevel from about here down. And now that bevel will increase the width of this about twice as thick, or twice as wide. So it's going to end up about that big, or that wide, somewhere in that range. But for right now, I need to clean off all of this junk because that does not forge well, especially on an edge. So we will clean this all up and use the big grinder and get forging. Well, that didn't take long at all. So you can actually see a little bit closer. There's the step for the tang. So that'll be drawn out to about that long. So it'll have a 5-inch handle and it'll get peened over, and I'll end up using steel instead of aluminum like the traditional ones are made with. And I'll have a chunk of steel up here, probably be out of an old saw blade, circular saw blade. They're actually not that good for knives. Excuse me, my nose is a little bit stuffed. They're not that good for blades themselves because it cannot be hardened properly. But it's the right thickness for our guard. I'll just curve it forward instead of back, like the Kabar versions. So, yeah. And then this will be our blade section right here. So this will be a 8.5-inch blade with probably about a 1/2-inch ricasso. Well, so it's basically right there is where we will stop hammering. Excuse me. I'm looking at the blade itself instead of the camera. So there will be a little section right here. I don't know if we'll put U.S. Marine Corps in there, as in UMCS, or wait, USMC. Sorry, I had to stop and think about that. But whatever we do, we will make a nice knife, and it will stay pretty much that thickness. This is a pretty standard thickness leaf spring. Some of them have a very drastic taper in them, which is great if you're making a big, nice chopper where you want that really steep taper from the front to the back, so you have a lot of weight out in front. But for this, the standard K-bars are made out of a chunk of flat stock and ground. The edge is ground, they're laser jet cut out, and the fullers are put in. with a CNC machine. So, to make it as close as possible, we'll have to try to do some machine precision on this and use our standard thickness right there to give us a little bit of a hand. So, let's go down, stick in the forge. First, we'll draw out the tang. Okay. So if we're going to work on the tang first, we need to figure out where we want our definition to be. So we're going to take that section right there, set it right on the edge of the anvil, and strike right at the top of it. Like that. And start to work that back. Up here. So it tapers from the shoulder down to the tip in both ways. Very slightly this way, and it'll be more evident if we get to grinding. But this part has to be the thickest part of the entire blade, especially if you have distal tapers and it comes to a rat tail tang or hidden tang. Now if you have a full tang, this does not matter. It can be as thick or thicker or however way you want to work that taper. But if you're going to have that shoulder right there, that has to be the spot that receives the most shock. So that needs to be the thickest point. This has to be thinner than this, because if it goes the opposite way, this is prone to breakage. But since this is going to be the same thickness all through here, it'll just have to taper down from here and we'll call it good enough. Oh, and the cuts, I've been using the pause and resume system on this phone. So that's why everything seems to be going the way it is. So I'm going to pause you again. We're going to work on the blade. Come back over the horn to the next heat. Give it a little bit more definition, and then we're going to bend the entire thing this way in a sickle shape. So when we lay it down and start hammering the flats, get an edge in, it'll bend back straight. A cold steel vaquero right now. Okay. It won't look this way for long though. That's about as much bend in it as I'm going to get right now. And I don't want to start pushing and get in places that I can get cold shuts along this edge. So this will be enough. It just gives me a baseline to start at, because then once this straightens back out again up here, I'm actually not sure whether this is in frame or not when I'm doing stuff here. So when this straightens back out, this will be the hump that then starts where the swedge is. So that'll be right there. And nothing needs to happen other than just keep this spine straight. So we won't be messing with that too much. It won't be down around here. And I'll start hammering from right here because we need a ricasso, an unsharpened part of the blade that is denoted by that just a squarish piece right here. So the blade will come out right here and keep forging. Try not to do too much hammering. We'll see if we can save the piece. Okay, so I ground out where the split was, but that got me a little bit thinner than I want to be, so I'm going to have to heat this back up and come in real gently with a smaller hammer just to where I don't start that split again. And make sure that I do not hit after that metal loses its color. Try to get this to expand out just a little bit more because I need it. It's a little bit under 1¼ inches wide. I want it to be a little bit over 1¼ inches wide. So we're gonna turn the forge back on and continue working. So I've gone as far as I want to go with that edge. So it'll be not as wide and it won't look exactly like a standard K-bar. However, it'll be close enough for our purposes. But because of that crack, I don't want to go much further. I want to make sure that I have good steel that hasn't started with a hairline fracture. So right now, it's almost up to temperature that I'm going to turn off the forge and let it cool down. Once it has cooled to the touch, I'm going to heat it back up again and let it cool to the touch. And then I'm going to heat it up, straighten it out a little bit, and heat it up again, and then we will quench it. Quench that in canola oil. We'll just have to get the tank. So we'll turn it off here. You can see in there it's glowing nice and orange. That's exactly what we want to do. Turn our gas off. And now we'll just let that cool down. And that warm forge will help it cool down even slower so that we can get all that grain pattern in the steel all straightened out, because we want that to be as tough as possible, because we're going to be doing some fun stuff with it. So I will be back once I have done the thermocycling and have my quench tank down here. Okay, quick step before tempering is you got to get her cleaned up and get all your profile put in, which we're going to be doing primarily with the grinder and a big flat file. That'll give us all of our really nice, clean, crisp, straight lines. But a quick tip that I pretty much figured out and learned from Michael Cthulhu, watching his videos, was use a wire wheel for the grinder, which has higher speeds than a standard bench grinder. And it'll knock off all of that forge scale and all the rust and everything that will end up gumming up your grinder and making it wear out faster. Because it is a little bit tougher to grind off forge scale than it is to grind plain steel. So, quick tip, it'll save you a little bit, and it also gives you a look at what things would be like if you were able to keep that cool pitted look that looks like it's like 50 years old. And it's been sat out in the rain and it just looks all pitted and worn. It's a really cool look, but it's not going to stay that way, because we got to put it back in the forge, and we got to do a whole bunch of grinding to it, and we got to do a whole bunch of other stuff to the handle, and we got to sand it smooth to where it's got a nice smooth finish for sticking through people's guts, or in our case, a block of ballistic gel. But I'm going to get to grinding on this. I don't think there is a good place for me to set you, so you'll just have to believe that I can grind well. Okay. Okay, we got to do some minor adjustment to the tang. It's a little bit off, but there is our facsimile of a Kabar. Interesting point about Kabars is the name came about from a misrepresentation of the name to kill a bar. Kabar. Kill a bear. Apparently, a fellow up in Canada had used one of Kabar's knives to kill a bear. And that was before they were named Kabar. Whether that's true or not, I haven't a clue. But it's kind of cool. So, what we're going to do, I'm going to heat that up, fix the tang, turn it around, let it heat up, let it cool down, since we got it all nice and cleaned up. Heat it up, let it cool down, heat it up again, and we're going to dunk it in our oil tank. And for the longest time, I was using anything that I could find. But you know what? The best quench tank I think you could get is one of these old ammo cases. This one is for 120 millimeter shells for 2 of them. It is long enough to quench small swords. And by that I mean a small sword, less than a 30-inch sword. Actually, 25 would fit, but that'd be pushing it. Since, I mean, you only want to quench the actual blade. You want to leave the rest of the knife soft to absorb shock. Or sword, excuse me. But this makes an excellent quench tank. It's got that nice rubber gasket in it. I can just clamp that lid right down. It's waterproof, so water doesn't get in my oil and oil doesn't get out when I'm carrying it around. And it is a sturdy container. So, we will also dip something in there to slightly heat up the oil. What we'll do is we'll get something long here. Probably this. Right here. This might work. This will work. Actually, this will probably work the best. Just stick this in on the other side. Heat that up. Dip that in. Simply because our blade is very thin now. And we want a very nice, gentle quench that will temper the edge, leave the spine soft, and won't split that edge. So we don't want another crack. That would be very bad with all the work that I've put into it now. Okay, so I'm going to straighten the handle and come back after I've quenched the blade. So we have a straight blade, a hard blade, it skates a file, and a very nice looking blade at that. We've got a good temper line that stops, oh, there we go, right there in front of the ricasso, or where it transitions from the ricasso to the tang, which will be good because I've still got to define that a little bit with files and get a good rounded radius in there, because there can't be that focus. Close enough. But you can see how acute that angle is. It's practically a right angle in there. There needs to be a little bit deeper radius, similar to what you see on the top. If it will focus. Actually, I need something to focus against, don't I? Yeah. There it goes, right there. See how that top is radiused out? The bottom is very sharp. That bottom needs to get a radius just like the top. That way, force is more evenly distributed. That's what happened on the glaive, actually, is that I didn't have a good radius on that fork, or the fouchard, and it was a very, very thin slice that formed a microfracture in it. And then once it was hit sufficiently hard enough, then that little microfracture just cracked the entire thing right off. So, for a critical part like the tang, we need to make sure that those points are very well radiused so they distribute the force evenly. So, that's our next plan. I think I'm going to make this into the first video, and then the next video will be when I'm done hand sanding. I don't think people will mind if I don't show a lot of hand sanding, but we'll be able to get a very nice edge on this. I don't think we will sharpen the swedge. Then it'll be like a standard U.S. Marine Corps K-bar. I did leave that section down there. A regular U.S. Marine Corps K-bar's ricasso comes out to the edge. But since we were hand forging this, I figured that since it was going to pull down anyways, I might as well leave it like that. So, it'll look a little bit different than the actual Marine Corps K-bar. But I think it'll perform very similarly. And what we're looking for is just how much will this weigh? How much weight can I take off? I'm guessing with as long as this is, and with as deep as I'll put the fullers, and with what I have to put the fullers in, I think we're going to lose 2 ounces, which if this turns out to be a, 15-ounce knife, that'll put it down to 13 ounces. If it's a 12-ounce knife, then it's going to be a 10-ounce knife. So while it won't seem like a lot, it will definitely end up being very helpful in the end, especially if you're counting ounces, like a backpacker or something who wants a blade for killing bars. So we will put this into the oven. I've had very good luck after quenching, putting this blade in the oven at 350 degrees Fahrenheit for an hour. And that seems to work fairly well. So that's what I'm going to do, and we will see what happens, because then I will take it out and we will do a bend test. Start of the first video. We'll see if it bends. We'll see if that tip breaks. I might actually go in after oven treating it and take a torch and run the temper colors again, just to make sure that it is going to hold up. That, with as thin as this is going to be a very difficult procedure. So hopefully I can just get it done the way it goes. And we'll do it, just do that oven temper. So, see you in the next video.